Good morning.
Good morning.
I just have a couple of important announcements regarding the next few weeks of the cohort that I'd like to go through with you from this nice slide that Yomi prepared for us. Okay, so today is October 4th, and it is our very last Saturday for the lectures and lab videos. Kudos, real kudos. If you're here today and you've been here every Saturday since the first time we started, you should pat yourself on the back. It is not easy to stay committed um, to this kind of unofficial learning path. It takes real commitment. So I really recognize and acknowledge that, and I am proud of you. And I hope that you're really enjoying your time here. You've been making a lot of friends, learning a lot, and it's been helping you in your journey, which is all that we want for you. So next week from now until the demo day, we wanted to just make a plan for you. We have like 4 more Saturdays. Before we were going to have the demo day on October 18th, but we were quickly informed that there is Data Fest and some of us are attending. So we decided to not have it then. And the following week, October 25, unfortunately, it doesn't work for me. And so we now have the demo day on November 1st. So it gives us about 4 Saturdays more, like 4 week more to really work on our projects. And I think it's good that we have this much time from the proposers and all the meetings that we've had this week with the team. It's really looking very nice, and I think the extra 1 week could really help the teams. But irrespective, momentum is really important because whether or not we give you extra 5 weeks or like 1 week or 10 weeks, it's all up to you to organize yourselves to work on the project, and getting an extra weeks may even for some people end up making them procrastinate. We hope that this is not the case for you. So on next week Saturday, there won't be community call, but I will repurpose that Saturday for a check-in, project check-in. When we met this week with all of the teams, like I promised another check-in closer in the next 2 weeks, to see where we're at now. So we thought maybe next Saturday we could use that the time we would naturally use for the community call to check in with the teams. And so since we're trying to get like a 30 minutes check-in for each team, it means that we can only fit in 4 projects within the 2 hours of our class. So we're gonna do like 2 hours in the morning, like from 10 a.m. to 12, our normal time. Um, Yeah, as I was talking about project checking on October 11th, I realized that I have a conflict. This is amazing that I just caught it now. But okay, maybe then I have to rethink October 11th. Yes, unfortunately. I won't be able to do it. This is unfortunate. Okay, so if the project checking in is not happening on October 11th, then we would maybe just do like a community call, like informal one, where Yemife can have a chat with you on what's going on within your projects, and I would have to ad hoc organize another check-in with you during the week of the week of October 13th, then like as we did this week. Apologies about that. And October 18th, there won't be any official class. So we encourage you to use that to meet within yourselves as a team. If you're not attending Data Fest, just to continue to work on your project. Then the following week, I'm going to do another check-in, like in ad hoc planning, like we did this week. So it will be the week of October 20 to 24, a 30 minutes call with the team to touch base on where you're at right now. And October 25, we can do like a mock presentation. So maybe just if you want to practice your sessions or do something, then October 25 could happen that day during the 2 hours that we have for scheduled for the community call. So it's going to also be informal, but like we are offering this if you would like to take it. And the project presentation deadline, like when you need to submit your presentation slides to us, would be October 28th. It should be on a Wednesday, if I'm not mistaken. And you would also be submitting your project report, which should be in the form of a readable notebook in your that is present in your GitHub repository. And on the November 4th, that will be the demo day. Since we have 8 projects, 8 teams, it's gonna be like 10 minutes ish for each team to present. And they would have around 3 to 5 minutes for any questions. And we're going to invite some of the lecturers and tutors for the cohort 8 videos that you've been watching to attend. So I'll send out an invitation to them if they're able to join. Then you also get to meet them and say hi and thank them if you would like. Okay, so that's it about that. And uh, yeah, we would also really like you to give us some testimonial. So maybe we can coordinate that um, on one of the community check-ins to share your experience during the cohort, or if you want to make a video by yourself, like a 5 minute video or even less or more if you want, and then you can send it to us and we will put it on our YouTube, like about like the testimonial from the um, scholars in the cohorts. I don't think we've done this before, but I think it's nice to have that for each cohort, how you're feeling. But we'll always send you some forms to give us your testimonial written form as well. But in addition to that, we would appreciate a video if you can make one, and we would appreciate your consent to put it on our YouTube channel. Okay, so sorry, this is ahead. Yemife will go over this when it gets there. But the last thing I wanted to mention is that all of your project GitHub repository are now on AI Center Lagos. If you go there, you will see these are all the teams that we now have their repository. There's one team um, left to be added here. We have a meeting with them later today. But otherwise, all the teams, project repository has been created or forked. Benokre from Uzundo is here. Um, yeah, this branch is behind. I'm going to sync the forks. And then within each team, you can also read their proposal. For example, this is for team um, what they intend to work on. So would be nice if you're curious about what other things are doing, you can go to their repository, read their proposals, and in the next week, what I'm hoping to see is more like details about the data set, what they're all working on, and then hopefully README that is readable. I really do like the team Benokri's README repository right now. It's very descriptive, shows the overview of the project, the data set they're using, the methodology, how to use the GitHub and expected outcomes and yeah, the team member. I think this is quite a nice one and can be used as a source of inspiration by other teams. Okay, thank you so much. That's it from my side right now. Do you have any questions?
Yes, I have a question. Can you hear me?
Okay, I can hear you. Yeah,
Morning.
good
So
morning.
from my side, I have an issue to join like less the last three sections. So I wasn't aware of like proposal and stuff. Can I now do it by myself? Since I don't know if there is any team left, uh, like do a proposal and then do my project and come and present it. Since I mean like people already work on the proposal already, everything.
Um, okay, that's a good problem to have. Um, do you already have like a project in mind? Do you want to do?
Yes, I since I'm in the health field, I think like I can do something on that, like work on the project, like maybe a prediction of malaria or something. But anyway, like since I'm in the health field, um, do a proposal, it will not be a problem for me. I know I can do something and then let you know.
Mhm. Yeah, that's it. So the thing is that we've read like today is the last day I'm wrapping up the project proposal discussion, and it's now all the teams are now in the phase where they're working on that project, and I think it's really important to not add more projects at this point, because for organization purpose, like all the project that is expected to be delivered needs time to be reviewed and also needs time to for us to actually follow through with what they're doing. And so what I would encourage you to do is to look at the proposals of all the projects that was submitted. It's publicly available, and I can share the link right now again in the chat. And in each of those project proposal, the team usually puts their like the number of team members that they have. So if you can find any that does not have up to 5 team members right now, you can reach out on Discord to that team to ask if they are interested in taking on another member, and then you can work together. And of course, if the project also resonates with you. There's a team working on predicting cholera, for example, which I think it's closer to healthcare that you're interested in. And right now, from what I see, there are only 4 members, and so the maximum is 5. So maybe they can take on one more team member if you are keen and they're interested. And most teams are really just in the beginning phase of collecting the data set, and only a few teams have gone way ahead of like predicting or modeling and doing exploratory data analysis. So I think if you reach out today, there might still be an opportunity to be a part of some of those teams that are not complete yet. Does that make sense to you?
Yes, it makes sense. Thank you so much for your suggestion. I'll reach out to them. I'll go through it and then reach out to them. Thank you so much.
Of course, no worries. I'm sorry we couldn't make this exception. It's just really hard to plan otherwise. Okay,
Thank you.
Ismail.
Good morning, everyone. Good morning, Yomfe.
Yeah,
Teju. Yeah, I actually want to ask about my team purpose. I think we've submitted it last time, but while checking through the presentations that you shared with us now, I couldn't find my team's
it's
proposal on the link.
Ismail, your seat guard, right?
Yeah.
No, it's there, right? It is the seat guard AI is in the proposals repository is also there. You didn't see it when I presented it just now.
I couldn't find it. That's why I was asking for the link on the in the chat.
Okay, I didn't. So this is the your repository, and your proposal is also in there. Team Guard. The updated one, I've already updated the proposal as we discussed. So you can, if you go into the docs, you will see two proposal. One is revised. The other one was the first proposal that your team had before.
All right, all right. Thank you so much.
No, of
Can
course.
we go?
Yeah.
Sorry, can we go ahead and add our readme there?
Yes, please. This was what I responded the last time to Elijah, that the proposal is good. Like now we should just continue working on it. And I don't know who's I think someone from the team should have access to the GitHub as a manager. And if nobody does, I would need someone to send me their GitHub that I can make the manager and they can add the rest of the team members. Um, yeah, so that would be the next step. I asked this via email, but maybe it was missed. I'm not the one that will be updating this repository, for example. I just have to create the repo. Really, your team member needs to take charge of it, and you start to work from that repository.
All right, maybe I will send my own because I'm the tech lead of the team, so I'll send you my own my own GitHub
Okay,
account. All right, thank you
okay,
so much.
okay. Okay, no worries. Well done. Good job.
Yeah,
And it like your new
yeah,
proposal is really nice. And I like how very laser focused it is now
Yeah.
on the problem you want to solve.
All right,
hello,
thank you so much. Thank you,
hello,
man.
Yeah, you're welcome. Well done. Okay.
yeah. I want to ask a
I wanted
question.
to
So,
ask Teju a question.
okay, sorry, mine will be quick. I promise. Mine is quick. So, like, you said something about the like our final deliverables, like the final submission. So, the final submission, I just want to confirm, to be exact, like, is two things that you're expecting from us: a well-detailed Jupyter notebook and presentation slides, right?
Um, this is correct. So of course, like including the link to deployed model if you are deploying it. But what is really expected, what would be evaluated, would be like a well-detailed uh, project. Well, what did I call it again? Is it out?
No
What is the English that I used? Report, project
report.
report.
Yeah.
Yeah, so well-detailed project report and also your presentation slides because you will be presenting and we want to make sure that you have everything there. And when you're presenting, maybe you probably have like a demo link somewhere, so you should include it there. And also in your Jupyter Notebook project report, you should include a link to the demo if you created one. So
Yeah. So like no, just to be because I just want to be sure, to avoid any ambiguity. When you say project
yeah.
report, do you mean like our like the Jupyter notebook we use to go through the whole process of building the model, or like a written report, like summary about the whole thing, or
Yeah,
Yes.
it's good you're asking to clarify. So, I think I would prefer the Jupyter notebook to be in the form of a report. And but if you want to write a written report outside of the Jupyter notebook, that's also something that can be done. In either case, the report should really summarize everything that you have done, not summarize, like go into a bit of detail on what you've done. But I wanted to share one that I found particularly like you, readable and nice from a past project from Sharon, I believe. Where is she? And we've shared this before earlier on in the during the cohort when we were trying to show you example project, but let's find it again. Just gonna search for Sharon because
I dropped it in
I can't
the
read.
chat. I dropped the link in the chat.
Okay, I'm sorry, I did not
Okay.
see it, but um this is it. You can see that she really went in to try to report what the project is about, the abstracts, the introduction, like the state problem statement, the materials methodology, and then data analysis. And it's more like, I mean, of course, you would not want to have all this output of Jupyter Notebook that is hard to read be there. Like in your final report, you want to clean some things up. But I think in essence, you can read through the notebook and you can kind of get a sense of what he's doing. And I feel like it's much more readable in this way. You see plots that she had and the final thing. I think did she do some modeling here and she conclude discussion and conclusion limitation and so on. And yeah, so this is what we mean by project report. Yeah. Okay. Does that make sense?
Yeah, yeah, sure. All right. So like, okay, I think this link, right? Yomifa just said he put it in the chat, right? So
Yeah.
if not,
And
if you give it
yeah,
to
there's
Yes.
no yeah, everything is there. Like there's a lot of information that you can use like if you're looking for inspiration. Like here's at the
yeah,
Legos has been running classes for quite some time now. So you can really go to the project and see what they did and see the ones that you like the most and then, mimic them. But this is one of the projects that we think it's nice and was able to like detail. But your GitHub repository also lives on, right? So like having a readable like a README that is descriptive and really nicely structured GitHub repository is always a nice addition. But of course, we're not judging you on this one right now. We're only judging you on your presentation and also on the reports that you submit.
yeah. All right. Thank you. Thanks so much.
No, of course. Any other questions?
I was trying, please, I have
I
a
think there
question.
was
Hello?
Hello,
proceed,
yes,
proceed.
please go ahead.
Yes, I was going through the project drive that you sent, and I realized that it is masked, so I'm not able to go inside the open the PDF file and read the content.
You're not. Did you say it was private? Sorry, can you?
Can you hear me?
I can hear you now.
Yes, I can hear you. I was saying
Okay.
that I'm not able to read the content of the PDF file because it is masked. So I
Oh,
cannot even know those who proposed the topic and then the project and then try to reach out.
Oh, probably it requires access, right?
No, no, it shouldn't, because the access for all the PDF in this folder says that it's anyone on the internet can view it. So, uh, is everyone else having the same problem? Can someone try to click on the drive and see if they can reach the PDF, any of the PDF? Hmm? Can someone confirm, please?
Yeah, I can read it.
Okay, thank you. Um, added
I'm
up.
trying to
Arika, can you
access it.
Hello?
can you try again, or
Okay.
yeah, if it's still not working, can I suggest that you maybe go to GitHub, where all of the PDFs are also there for each of the projects, and maybe try to read it from there. Like
Uh,
all the project proposal for this cohort starts with the GitHub name, repository name C9, which is called 9. So if you see C9, so it's for the projects for this cohort.
Okay, ma, I'll just go through it.
No worries. If there's still a problem, you can text me on Discord as well, or
Okay.
during on chat. Ismail, did you have
Hi,
a question?
Yeah, thank you.
I have a
So
question.
do I still have my ass on? Sorry, I don't have a question.
Okay, no worries. Chitom, you wanted to say something?
Yeah, I wanted to say something. So, I don't know if you remember, there was a time like when we had our call. So you made when you created the repository for us. I think you made one of my team members do this thing because my username
Yeah.
wasn't different. Yeah, so I don't know if you can try because I tried to text the guy, but he hasn't replied since. So I don't know if since like you already talked about it.
Okay, Chitom, what's your username?
I'll type it now in there.
Yeah, Chitom, you're Wakwa, right?
Yeah, yeah.
Okay. Do we have any other questions, comment, feedback? All right. Thanks a lot, everyone. Yemife, apologies I took a lot of your time, but we can continue now.
No problem at all. Hold on. I think this is we are getting to the stage of really I think at the most important we are already at we are almost at the stage where it will end. So all these are really yeah. So okay. Okay. Now to the material for the week. Now to the material for the week. Okay, like let's do let's do a quick run through what the material for the week. Hope I'm still audible. Am I audible?
Yeah, I can hear you.
Please, if I'm still audible, let me know. So, okay, I guess I haven't been logged out. I guess it's a bit stable. Let me share. It said you I'm requesting access to share my screen.
Can you please try again? I made you a
Okay.
co-host.
Yeah, yeah. Oh, is my screen now visible? Is my
Yes,
screen visible now? What can you see?
welcome to AI Saturdays Week 10 community call.
All right. That's all right. Also, AI Saturday Lagos. Once again, this is the 10th week for this is the 10th community call, and we appreciate everyone, for coming. Thanks for sticking with us till now. Yeah, thank you. It's been a long ride. Thanks for sticking. Welcome to the last week of lecture. So even though next if as Teju said next week there won't be like an official call, but we'll have like an unofficial call. And if you have questions, probably if you have questions, anything you want to talk about, and if it's for those that are still trying to catch up with previous lectures and so, if you have questions that you want to ask them by, so you can also come with your questions that day. But we'll be treating basically anything and everything. You get so I won't just be limiting it to a particular lecture. So yeah, welcome once again to the last week of lecture for the cohort. It's been a long ride, and yeah, thank you. So recap of weekend's material. Introduction to um deep learning. Okay. I think I can skip the post one. I think we already have this. Um, so what do we understand by deep learning? This is a community session where I am supposed to assume that we all like watched um material, even if it's just the first, but I know most of us didn't. No, that is for but regardless, anybody wants to give it a shot.
But let me just go. Let me just say it how I think it is, especially after learning from
Okay.
the week's video. So deep learning is like a subset of machine learning where we have like a neural network with multiple layers doing the prediction, like modeling the data after neural networks with multiple layers. Yeah, that's what I'll define deep learning as.
Let me just say this. I know some of us might have heard about try, people trying to like okay, deep learning was you was inspired by human brain. Let me generalize. How to a very like neuron. Okay, let's see. testing my patience today. So am I audible?
You are, but you're kind of breaking.
It's-
Hello, or is it only me that feels that he's breaking?
yeah, yeah, yeah. Can you hear me? Can you hear me now? Is it still breaking? Am I still am I still audible?
Yes, you are audible now. At least better than before.
Am I audible again? I don't know how we are going to do this with conversation, but let's say it's frustrating my life today. Am I audible again? Am I still audible?
Yes, you are audible now. We are audible.
Okay.
Mm.
Let me let's see how far I can do. Okay. 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 This is a this is a new this is a human this is a neuron which, which is which is designed after this is a neuron of this is a sample neuron of human brains, and this is how information is being transferred through our nervous system from the brain through every other part of our body. Is one thing is once we see we are able to humans are able to like process stuff like in milliseconds. Okay, seeing this now, I know that this is a picture and I can easily read the picture. But now, what to transfer this, the way human can understand information, the way human can like process information. We are trying to like model it in computers. So that's okay. When else sees my face, say that, oh, this is your face. When it sees this picture of it, then it can say that, oh, when it sees a picture of a cat, it can say that this is a cat. When it hears when it hears the particular language, say that, oh, I understand this language and I can speak it. Oh, and if you train it on a language that it understands, let's say you train a model on your language, then you can speak to it, you can like pass information to, and it will respond to you. So basically, that is what birth deep learning that was trying to like not exact trying to try to make machine understands complex information, even though we're able to see pictures and we're able to like say that this is what this picture is saying. We're able to see stuff and say that this is what it's saying. As much as it feels like a very simple task to humans, it is a very, very complex task for computers. So try to replicate this feature that humans like that is like inborn, that comes naturally to humans. We are trying to like replicate this I try to model it into machines. Does that make any sense? And am I still am I
Yes,
still
you
audible?
are audible, and it does make sense.
Okay. So okay, now it's, what you are saying that deep learning is a software of machine that focuses on artificial neural networks and their application to solve complex problems. If you've been so far, throughout for the past 9 weeks now, we've been talking about stabilized data sets. We'll be talking about, before you can do the predictive algorithm, you need to have your data sets in a tabular form. And you like have a okay, probably you might have a target, or you like want to classify them, or recommend or using recommender system, or you want to you want to group them. So one thing is, so far we've not talked about pictures, we've not talked about just text, we've not talked about audio. There are lots of other applications that we need machines to be able to like do for us. But this machine learning algorithm that we talked about so far, they cannot like do that. So this is so far we've been talking about tabular data and it has been just text in tabular forms. But if I want a language model, if I want an AI model to process what I am saying, or to process this particular information, the algorithms that we've been studying so far, they cannot do this. That but this is where deep learning shines. This is where deep learning and neural network, this is where they shine. Once if you are doing a machine, if you are doing tabular data sets, anything once it is tabular data set, all these tree-based algorithm, they work very well they are very good with tabular data sets. But when we now move to, another tabular data set now, we call this structured data because we can get it into a we can get it into we can get it into a pandas data frame. What do we use pandas to do? Do we remember? What do we use pandas to do? And what is pandas itself?
Yeah, pandas.
Uh,
Pandas is like a library. It's a Python library
I thought.
that's used to. It's a Python library
I'm
that is
aware of it.
used to keep your. That it has data structures like data frames and series. Like you used to keep your data in tabular formats. When you're in your Python environment. Yeah.
it's used for data manipulation. Yeah.
So
Okay.
Panda is using for data manipulation and
Just
manipulating
for
data from. Yeah.
Python.
This is the 10th week we'll be using pandas for apologies once again, everyone. I don't know how. We are going to, don't worry, we are going to scale through today. I'm going to scale through today, and I don't have the backup internet. Yeah. Okay. So let's see what Wikipedia. Okay. Let me go to this. Let me go. Look at this. Panel is a software library written for Python. So what we have been using so far is we use it to like manipulate data. We use it to like when you want to you want to drop now, you use pd dot something, you use pd dot something. You have been using pandas data frame. You have been using pandas to do all this data manipulation and stuff like that. So because you can get them into like a tabular form, and you can just like present it like that, you can just like see it. That is why we call it a structured data. For unstructured data now, images, sorry, I should not have said. Exactly. For other examples of unstructured data, everybody wants to tell me. What's another example of unstructured data?
Yeah,
Am I still audible?
email, like email. Is that like okay? Like email. You said videos before, right? Yeah, I don't know if videos are
We
if we
have
can say videos again.
audio.
Yeah,
Music, or audio, music, audio, videos, they are all um audio. I just like passes there. I just like and just like pass it to a, even though we are not passing a structured data, so we are not passing directly to into a model, we still have to like first transform it into numbers that the machine can understand. But then we need further processing to make it like structured, to make it into a structured way that we can pass it uh, into our model. So yeah, so this so deep learning and neural network, they shine when yeah, especially in unstructured data. They can also be used in structured data as well. I think in the lab, you see in the lab, in today's in the week's lab, we shared this news. We see that this keras, software keras was used to train a classification model on iris data and the iris data set. So you can see it. So this is our target. This is the model, and yeah, this is the training. And you can see the model accuracy and the model loss. So let's come back. So we can also use it, but it is not really necessary. I don't so personal from my own personal, like, from my limited personal view. I think once if you are using if you are using structured data, um just stick with the traditional, I say traditional, just stick with the tree-based algorithm. But we are now going to what's it called? We are going to unstructured data, then you can stick with it. But it doesn't mean you cannot use it. You can use it. I don't think it's necessary. And why? Okay, we'll go into okay. We'll go into that. Why? So if I don't remember to talk about the why, someone can ping me later. So okay, what makes this deep learning special and able to solve problem rational algorithm? Okay, if you remember, in of course you should still remember, while building our model or building traditional true-based model and algorithm. You need after building your baseline model, then you can do feature extraction to extract more features from your model. So probably if you have a, let's say you are predicting house price now, you have a land size, you have let's say you have bedroom, you have the square meter of the bedroom, you have square meter of the bathroom, you have the number of bedrooms, you have number of bathrooms. So in that kind of feature, I can say that okay, you will have to do feature extraction. Say okay, um, now you can do a feature extraction. Say okay, ratio of bedroom to bathroom. You can do bedroom to bathroom ratio. I can also do the number, that is the number. I can also do and probably land size to ratio of land size to ratio of probably the house size or probably the living room size. Or yeah, you can just like try out a lot of things that if you make sense. You have to do that before you eventually pass those features now into your algorithm. But in what's it called, in deep learning, you don't necessarily, even though you you can, but you don't necessarily really of, let's say okay, let's say we pass this particular image, this screenshot that's on this slide. Let's say I pass this particular screenshot. So into a neural network. Now let's say at some point, at some point at some point it will say that okay, this is yellow, this is yellow, this is yellow. Okay, let's focus on the yellow. At some point, you say that let's focus on black. At some point, you say that let us focus on the text. You know, okay, these ones that are bold, that's those ones that are in bold. Let us focus on that one at different points by itself. I said, okay, oh, these ones are in white. Let us focus on those ones. You said, okay, probably at this point, let us do it. It is not, you are not telling us to do it like while it is training. You are not telling us to do it, but by itself, it's like extract these features at different points. We cannot specifically at in a fifth or neural network. You cannot specifically say that this at this point it is focusing on bold. At this point, it's focusing on lines. At this point, it's focusing on white. Do you get? But the thing is, it does it right. So does that make any sense?
Yeah, yeah, that makes sense. Yeah.
Am I still audible? So, but the thing, but in image, in while we are doing this convolutional neural network, we are doing for image and that. And that is where picture. You can say that is probably like processing and um feature extraction. So that one you can augment on your image so that to ensure that you zoom. There are times you zoom the picture in and then take a snapshot. This for okay for I want to pass this image, this particular image. I want to pass it. I can take a screenshot. I can send a picture of it at this size. Now I can also send a picture. I can also take a shot of it at this size as well. I can zoom further in. I can tilt it at a particular angle, like to the left, to the right, and do some distortion just to make it just to make my convolutional neural network robust enough. I think that is one thing that I can do with images, but I'm not sure that is possible with text. I've not seen that with text, and also audio. You cannot how do I explain audio now? Okay, don't let me go into audio. Audio is a bit more technical than this. Let's stick with image and text for now. So yeah, so and versatility is versatile to and applicable to various domains, including image and speech recognition, natural. And yes, deep learning like shines when there is enough data, when there is big data. So we use large data. It's for your model to be robust enough, for your model to be able to generalize profile, we need large data sets. This one in your project now, I see that some of us are using like probably 1,000 rows, probably yeah, a few thousand rows. But when you're doing when you're doing um, deep learning, yeah, deep learning and neural network, you need you will see that okay, let's check the size. How's the size of chicken skull? Um, okay, sorry, I want to talk about the amount of parameters. I want to check the number of parameters. Um, um, Oh, okay, okay, private Nigerian. Okay, let me check. Okay, let me check. An open source model. Which one? Okay, Llama, Llama 3. Llama 3. Parameter. Okay, now Can you see this? Am I still audible?
Yeah, yeah, you are.
Please don't scare me. Let me
Yes,
know if
out.
I'm audible. Like,
Yes, you're
well,
audible.
not
You're
that
audible.
I'm. Please, if I'm not audible, if I ask, I just want to be sure that I haven't lost connection. So look at this now. You said that okay, look at this model. 8 billion, 8 billion parameters, 17 billion parameters, and 405 billion parameters. We're talking about billions of parameters, and this will be hundreds of gigabytes. This model, this especially would be like with hundreds of gigabytes, and you want to run it. If the model alone is just like this, and these models now, if you are running it on CPU, it will be slower. You need GPU. Do we know what GPU is? GPU. Does anybody know what GPU is?
The graphic processing unit.
Yeah, unmute yourself, please. Yeah, yeah, I know it's graphic, but like what is why you want to speak?
Yes, yes, yes. I wanted to say something. Here's the thing, like working on GPU and CPU of a thing, is it not advisable to be using VS Code to run .IPM?
Proceed, proceed now.
Can you hear me? Sorry, can you hear me, sir?
Uh, my internet. I lost my. Okay, okay,
Yeah, I
okay.
was
Yeah,
I
I
was
can hear
asking
you
that
now.
is it not advisable to be like basically using VS Code if I'm considering GPU versus CPU stuff?
I am back. Sorry. Yeah, proceed is my end.
All right, my question was that considering GPU versus CPU stuff, is it not
Mhm.
advisable to be using VS Code? Like I'm using VS Code to do my Jupyter stuff. So is it not advisable to be using it considering the larger data sets or model?
Mhm. It's large um large data set. It is when you're doing heavy composition, so you're doing heavy stuff. It is GPU has support for heavy laptops. Like I said, that probably a laptop might have maybe like 16 gig RAM, 32 gig RAM, and my just come with only probably 4 gig GPU or like just this so amount of GPU. So the thing is, GPU are very like they are very they are expensive and they are very computational, like they have high computational support. So if you are running heavy, if you are originally they were made for if you are probably people doing video editing and heavy gamers, people that game, people that do games, that they majorly call those laptops with GPU. They call them gaming laptops. But that's because they have graphics cards and which is GPU that helps to this run this game data access, the larger the model you are trying to train, also the larger the GPU you need. So if you for training a model now, there is no, you can use am I audible again?
Yeah, yeah, I can hear you.
Today is the day. Okay. So as I was saying, you can you to train a model, you can use whichever one is convenient. One thing you can use for experimentation now. For experimentation, I think for experimentation now, everybody, I think majority prefers like using Jupyter Notebook. So it can be Jupyter Notebook, it can be Collab, it can be whichever one. But for science, machine, but we are not going. Am I audible again? Am I audible? Hello. Am I audible?
You are now. You are now audible now.
Ah, I don't know. I don't know what I did to it since people. Because- Okay, so as I was saying, um, what was I saying? Okay, I was talking about so if you so you can use whichever one that is convenient for you for experimentation. You can use it, but when you are going into production, we only use Python scripts, you know. So which will work effectively with VS Code. So you can use Python scripts to go into production. But when you're experimenting, you are trying out different stuff. You can use you can connect a collab notebook, or you can connect a VS Code to a GPU. If your GPU wherever your GPU is, as you can connect it. But that is for so then when you are training a model, you can always know. But when you are going into production, then you must switch from a Jupyter notebook to a VS Code. Does that make sense? You get it? Is that what you were asking? It's my
Yeah, yeah, I get you, sir. Thank you so much.
was that your question?
No, actually, my question was that um is it advisable to be consistent, like mean that using VS Code as as the main environment to work on training model, considering the larger data sets. So
Okay,
that's
oh,
what
oh, okay, okay, I get it now. If you are training a large data set, and you want to build a neural net, you can use your CPU. You can use VS Code if you are able to like connect it to your to a GPU. So if your laptop has an in-built GPU, you can use VS Code and you can run it on your laptop. Or and if you also have access to external GPU, you can run it on your VS Code. You can run it on your VS Code. But if you want to access free GPU, free GPU, like once on collab, okay, let me show you. Let me show you for okay. This is okay. Okay. Okay.
Hi, Mfe. I don't know. Could you try
Yes.
when you want to present? Could you maybe turn off your camera to save the bandwidth a bit so
Oh,
that
oh,
it
oh,
doesn't?
okay, okay, okay. Okay, let me try. Um,
Because I observe is when you
Let me
present.
turn off my camera. Oh, okay. Okay. All right. Let's let's extract that as okay. Um, are you seeing? Okay, guys. Okay. Yeah, I wanted to show you this. So this is so we can see connect to a hosted runtime. Let me change runtime type. Okay. So this is CPU, this is GPU, and this is a TPU. Are you still seeing my screen?
Yes.
Yeah, yes, yes,
Am I audible?
yes, yes,
Yeah.
Can you see this? Can you see this pop-up?
yes,
Okay. So you can see CPU, you can see GPU, and you can also see a TPU. So this is what laptops
Yes.
come with, and this is GPU. This is a T4 GPU. So you can also you can this is what if you are trading. This is why if you are trading a model, this is why most times come lab to access this this GPU, which will make our code run faster and more efficient. That is why we are running on faster on larger data sets rather, and especially whenever when you are dealing with deep learning models. So this is also a TPU. So this TPU is also this TPU is provided by Google, and it works well with Jax and Keras. So because it is also really optimal because Jax is also from Google, this CPU is also provided by Google. So if you're recording in Jax, probably if you're recording in Jax, or if you have a TPU, then you probably want to like go with the Jax or you want to go with the Keras. Yeah. So that was just by the way. And so I does that make sense? It's my
yes, sir. Yes, sir. I got you, sir.
so it's because we can get free because we can get it for free. That's why we are coming to like GP. That's why we are coming to Polar. I know some Mac also has a there's a name they call the Mac GPU. It's not really GPU, but there's a name they call it. I forgot it. So yeah, so big data and yeah, so this is where deep learning shines. So yeah, it is a subset of machine learning, takes development of algorithms, learn patterns. So the, these unstructured data, they are much more complex patterns that the machine has to learn compared to just structured data. It has to learn different patterns. It has to like learn different structures between them before it can come up with a solution. So yeah, so everything we have talked about, loss function, gradient descent, linear risk, all of them are still applicable and even will be much more pronounced in deep learning here. So the basic units of a neural network, of a feedforward of a neural network is what? A a a feedforward neural network, a basic yeah, deep learning model. It can be called an aggregation of perceptron. I said, did we talk about perceptron? I said, we talked about, I know that one of the lecturers talked about perceptron, but I don't know if I was able to talk on it during the call. But okay, let's say okay, this singular is are you can you still see my screen?
Yes. Yes.
Okay. So
Yes, sir, I can see.
this singular one. All right. We can call this singular one. We can call this a perceptron. A single one. We can call it a perceptron. A perceptron is just one. It's just a single standalone neuron. Just a single standalone neuron. So you're passing. So a perceptron itself is a form of a linear of a linear is a linear model. Okay. Perceptron itself is a linear model. Okay, so look at this. A perceptron is the simplest type of artificial neuron, blah blah blah. It takes so you say once is a so when you give it's just like example of a like the same way with linear regression and all this linear classification. But for it to be able to do for it to be able to like for it to extend to and be able to understand complex information, we have a lot of what's called non-linearity, which are called activation function. We'll talk about that in a bit. Are we still following?
Yes, we are.
Yeah.
Okay. Okay. So this is okay. So mind you, do we still we still remember the concept of loss function, right?
Yes, sure. Yeah.
Yes.
So at every point, so every in machine learning we always like predict the loss because this loss will tell us how good or bad our model is performing. So of course, and as we know, it is different between the ground truth, which is the original label, and what our model tells is telling us. So the lesser task a neural network, um, depending if you are doing a classification task, if it is just two tasks, let's say I'm just doing with let's say my classification is going to see a dog and a cat. If I'm classifying dog or cat or true false, then that is just so I use a binary cross entropy. If it is multi-class like dog, cat, rat from three and above, I use softmax. I mean, we use softmax, which is like categorical cross entropy. But if you are doing a traditional model, if you are using a traditional model like normal XGBoost, then and tree-based models, if for a classification task, what do we use to evaluate the loss or error? Am I still listening?
Sorry, what you asked the question? I didn't get that.
I said I talked about these binary concentric loss and categorical concentric loss. Do we understand the difference between these two?
Yeah, I understand. One is for like binary classification, one is for
Yeah,
multi-class
exactly.
classification.
Multi-class, three and above. Yeah. So I said if you are doing classification task for a traditional model classification task, what are the metrics that we use to evaluate the loss or error?
Uh, Accuracy, precision, recall, right? Isn't that what you're asking?
Yeah, F1 score.
Before, sir,
I was saying that, can you come back on the session? I'm not able to get you.
I should repeat the question.
Yes, sir.
Yeah, I said that what are the evaluation metrics we use for classification tasks for traditional models? Traditional models, I mean, when you are using tree-based algorithms now.
Okay, mostly when it's for classification, we use cross entropy, um, how they call it again? Precision, accuracy, and so on.
Uh, we don't. Okay. Anybody else wants to give it a shot? Thank you for the response. Anybody else wants to give it a shot? Okay. Don't be confused. Hmm? When I asked, "Are you sure?" I'm not trying to. I'm not trying to. Like, I'm not essentially saying that you are wrong. I'm just asking if you are sure of what you are saying. You need to be confident. For classification tasks in traditional yes, we use
Yes, I'm
accuracy,
sure.
precision, recall, F1 score, rock score. Yeah, lots like that. And usually I also operational matrix which help us to visualize error as well. So please, when I say are you sure, I'm not necessarily saying you are wrong. I'm just like trying to I want you to be sure of whatever you are saying, not just okay. Is that okay?
Yes, sir. Yes.
So what about regression tasks for traditional models? For tree based, let me just okay, don't MC true, don't MC traditional, let me say tree based models. For regression tasks for tree based model, what are the evaluation metrics we use?
Metric like mean square error, mean absolute error. Yeah, I think mostly they use both. I don't be able to remember. Yeah, mean square error and mean absolute error. When we have outliers, we use to mean
Okay.
square.
We also RMSE too.
All right. Thank yeah. Yeah. We use I use mean square, we use gross mean square. I also use mean absolute error. So root mean square error is just taking the square root of the square root. That's RMS. So yeah, so I just wanted to be sure that so when we want to be sure that we still remember what we did because we're building on top of what we have done. So that is that. So and I hope all remember the concept of this gradient descent. So anybody wants to explain what gradient descent is to us rather. Tell us what you understand by gradient descent. This is already a picture, right? So just like explain this. Anybody?
Yeah, I mean, gradient descent is like, as it says, literally, that's the sentence is there is what I'll have used to explain it, right? It's an optimization
No,
algorithm
proceed.
that uses it's an optimization algorithm that uses it's an optimization algorithm that is used to like minimize the loss function, because basically that's our goal when we are building a model, like to get a model that minimizes its loss function the most. So gradient descent is like an algorithm that sort of helps do that, by finding the derivative of the uses the derivative of the loss function and then walks backward, like in the opposite direction, like in the negative direction, so that it can reach the minimum, right? The lowest possible points of that loss function. Yeah.
Yeah, and how does it do that?
Like I said, it does that with by like
Okay, can you
taking
relate?
steps.
Okay, can you relate it
Like
with the learning rates? Relate it to the
yeah,
learning rates.
yeah. So like I said, it does that by moving like an opposite, like negative direction. And it moves in steps, like sizes of steps, right? So um like size, like how fast it will move
Mhm.
in the opposite direction so that it can locate the global minimum. So how the speed with which it does that is what we call like the learning rate, right? And like as usual, the learning rate has to be like optimum so that you don't um skip the global minimum, or you don't get up, you don't get into a situation where you never get to the global minimum because you're stuck in local minimum, something like that. Yeah.
Okay. Thanks so much for that. Thanks so much for that. So I posted the um attendance form in the chat. So please do also fill it. Yeah, that's basically what graded is. That's basically what graded is. So I hope that is clear. I don't want to take time on that. And this is what so learning step. So this is learning rate. So this is what is was about. I brought back. So you take these steps like down, this down. So when you are here, you calculate, you do the gradient. When you calculate the new weight. So you move this, you move our our learning rate was reducing. As we were taking little steps. We're taking life steps. We were so it was first so it was and doing enough. We are taking two small steps of life. But this so now look at this. So as I said, I was saying this that concentration is the simplest form of biological neuron works in the human brain. So yeah. We can what do we do? You see. So the inputs, we all know the inputs, and we have already talked about this, which is the importance that the model attached to each of these features. So and as we said, this am I audible?
Yes, you are.
Am I audible?
Yes,
Okay.
please.
So
Yes.
we've already explained the concept of these inputs features, which can uh in the lab we'll see that okay there are four features which there are four features, so that is those four features are x1 x2 x3 x, and then the weight, this one we are not going to provide, this is the model that attach this weight to each of these features. And how do we get the weight? How are they initialized? How are the weights initialized? Have we forgotten? Who
Sorry, like
wants to help us
I
out?
didn't get. What do you mean by, like you said, the weights? Like, do you mean for the neural network? How they are? I don't get. Hello?
Yes, now wait for the neural network. How are they initialized? Like
Like
normal weights for machine learning models. How are the weights
the
initialized?
weights are like they're like the, what do you call it? The coefficients now for your inputs, right? Is that what you're expecting?
Uh, the way I said the weights are initial. Okay, the weights are initialized randomly.
Okay, Ryan. Okay, 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 okay,
I
okay,
think
okay.
that's which is why. Please don't be confused. Thank you for that. Thanks for the attention. The weights are initialized random, which is why the learning, which is why when we start, which is why the error can be as high as this because weights are
Okay.
initialized random. The model is seeing your data for the first time, so it doesn't know how to the importance it should give. So it just gives random value. So the random value is now like evaluate is like so how far is this thing I did from the right thing? So and then it's trying gradually tries to like improve till it is now at this point, which is the best model. So that is about the okay, let's proceed. Um, so let's talk about classification function. I told you that a perceptron is basically a like linear algorithm. So when you pass it into it, it just does a linear it just does processing of what you pass into it, the weight, the the features and the bias. We get it. So this weighted sum is just like WX, which is MX. So that's just what this one. So weight corresponding with MX and you have. So this activation function, it is now the one that's now introduces non-linearity into our model. Um, but a perceptron itself is a linear is a linear algorithm. It's a linear algorithm. But when you add an activation function, depending on the kind of activation function you add, so it now adds a bit of non-linearity. So it doesn't just like think like straight like with like a linear algorithm. It considers multiple options and multiple like patterns, and of course the outputs. So yeah, so these are some of the activation functions that we have. We have ReLU, we have linear, we have sigmoid, and if you are using ReLU, if you are using linear, that's similar to you just saying that okay, this is a linear function. So you are just not doing a linear regression, classic linear. This point where you want to output. So we measure the outputs for what's called you are doing binary classification. Don't worry, all these things are looking theoretical. We'll go to the lab soon. Oh my god. Sigmoid activation. And
So
then, so
I wanted to
so
ask a question. Though. Is it possible, or do I wait for you to finish this part? I wanted to ask a question about activation functions.
proceed, proceed.
Okay,
Mm-hmm.
okay. Sorry. So
Proceed.
that, yeah. So that slide that you have now, the one before the one where the instructor defined what activation function is, right? Which is what you're explaining now. So you said
Yeah.
it introduces like it introduces non-linearity, right? And you also said that
Mm-hmm.
perceptron
Mm-hmm.
by default. A perception by default is like a linear model. So now I have never done like a, even in when you're explaining and learning deep learning, all the time, like they always use classification to start it. So personally, I've never seen, I mean, I know that there are deep learning models that are used for regression, right? But let's say we're looking at a regression problem now, a linear regression problem. You have done your EDA and you can ascertain that, with utmost certainty that the relationship between the features and the targets are, the relationship is linear, right? So now if that's the situation, the relationship is linear and all of that. If you're building your deep, your neural nets, right, build, that means that there will be no need for an activation function or an activation layer if the relationship between the features, the targets, there is linear. Yeah, that's my question. Like I'm saying that, does that mean that when you're building your model before compiled, there will be no activation function or active, yeah, something like that in like the last layer or something. So,
There is a linear activation function. Okay,
okay.
which is also similar to we not actually like, which is, so you see f of x is which, so so if just doing that little, you might not, so you might, as at that point you might not necessarily need to use a activation function. Do you get?
Mm, okay.
So
Yeah.
if you are sure, and as I said, majorly all these stuff, the ones that don't to, like in real life in everything, don't don't really use this for tradition for normal tabular data sets. I think you should. I always, so far personally, I stick to the normal tree-based model, tree-based array for all those kind of tasks. But so will give you. But if you are sure that this is a linear problem, you can just use linear activation, or you cannot, or is either you write linear or you just like don't put anything. Is that clear?
Yeah, that's very, thank you so much. That's perfect. Thank you.
Hello?
So seed, as I was saying, seed
Hello?
model, yeah.
Hello?
Yes,
Yeah, sorry. I was struggling to
who's
hear
speaking? Okay, yeah, can
yeah,
proceed.
yeah, I'm talking. Yeah, I was struggling to hear his last question. So I don't know. I just wanted to clarify what he was trying to say, whether, because my network was kind of breaking. So, like, was it was he trying to ask about if hello, can you hear me? Hello? Okay, yeah. So was he trying
Yeah, I
to
can hear
ask
you. I can hear
about
you.
if the activation
I can hear you. I
function
can
is
hear
going
you.
to be needed for a purely linear problem or something? I'm just trying to get exactly what he was asking because I could not hear what.
Yeah, I guess that was what he was trying to. Yeah, that was what he was asking. That was what he was asking. So he was asking if like if he's sure that it is a linear algorithm, the model that does, is it necessary to um to use a to use a to use an activation function. So that's, so I said yes, you can use a linear activation function, but by default they are linear. So you can just like use linear, or you can use linear, or you can just like use an activation function. But what I was just telling that, if but when you are doing, or you are doing or you are doing stuff that has to do with that has to do with, what's it called? That has to do with tabular data sets. It is always advisable to just stick with tree-based. uh, You get. So that was what I told him. There are
Oh, okay.
some. Do you get?
Yeah, I understand. Thank you.
So I want to drop some. There are some links that I found, and I want to drop. Let me see. Okay. So this is for that are interested in further readings. So you can read more on. I want to do the translation function. If you watch the material, because translation function different functions and they can be what's it called? Like going into details explaining translation function is a whole field is a whole that would be a whole lecture on it. So I just want to like draw some. Yes, I'm sorry for everything. I'll find the fix to this by not okay. So let's go back. So if you are also if you also sigma function, we use this. If you are doing a binary task, we use the sigma function at the end. If you are doing a again, I forgot to add uh, what name was this calculation function we I forgot. Yeah, this calculation function. Um, smart, smart classification. So this coming back, this linear, this sigmoid and this sigmoid, as I said, we use this majorly as the end of at the end of the model of classification class. Sigmoid, you use that one for multi. If this is just for binary, if it is binary, you use sigmoid. If it is a multi-class, you use soft multiplication function. So that one gives us so you can use multiple, you can have multiple you can combine it into so let's say at the end now so you can give like a what's it called? A probability. Okay, what's the probability of probably I gave a picture to a model now and I'm asking what's the probability of this picture being a cat? Though it's a cat dog, but I'm asking it, of course it doesn't know that it's a cat, but I'm asking what's the probability of this picture being a cat based on your training data. So probably this model have like different animals, cats, dog, mouse, everything. So it's now return a probability of okay. So probably this probability of this picture being a cat, dog, like that. So it's give a probability of everything. And of course, so that it is say if it's not, and of course, if my model is working as it should, then I should guess the major probability like on a cat. Is that making sense at all? Uh, Am I making sense
Yeah, I
at all?
feel it.
Or
I
I'm
feel
sorry,
it,
I'm not
boss.
with
Yes, yeah.
Yes, yes, boss.
I know this is a bit advanced. This is we are going a bit from our comfort zone into more advanced. I'll tell you this is basic introduction to deep learning. So everything deep learning. So this is still just basic deep learning, not um this is basic deep learning, not functional neural network and then or correct neural network, long short-term memory. All of this, everyone now even gets to transformer mechanism, transformer the attention, transformer architecture, and the attention mechanism and stuff like that. So please, for everybody that will be interested in going further into artificial intelligence, probably we want to work for and want to probably for proper AI. I mean, you are doing machine learning. Who wants to work on AI stuff, wants to work on probably all these large language models, ChatGPT, stuff like that. Then you need to like understand this concept. So it is not hard, but you just need to you need to be able to like conceptualize everything like that. So that's basically it. So we all understand. So this is I was talking about perception. So like as we all know this is the bias. This is feature, the weight plus feature and the weight. So we add them together and pass it into the perceptron. And whatever the solution is, this is just as this is I'm just this is how so this is how the spectrum works. So, and the weight and the feature. So once I add them, I will ask the bias and that's just what or you add this and then it's now passes into this this is also this is a kind of activation function, this step function. What it does is that if your value less than zero it returns zero, and it's also a form of classification algorithm. So it's just like a it is if it is zero and above, it returns probably true. And if it is less than zero, it gives you false. So that's basically so this is simply how a perceptron works. Do we get this scenario? Do we get this?
Yeah, yeah,
Please others that are
yeah.
on the top, please I will just let me know if you are if it
Yes, no
makes a lot
problem.
of sense. So okay, let me see how many slides I have to count. I have 8 more slides. And okay, I will probably by 12, I will try to run through everything, and then by 12, 15, I'll just like do a run through of the lab so that. Yeah. And if we have further questions, yeah, what's called, you can ping me on the Discord channel, or probably by next week, or come again next week. You can also like let me know as well. So okay, now neural network as severe perception. So I know I told you as looking at this particular example, see that okay, this 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 is one neuron, right? This is not a neuron. These are not neuron. These are input. This are both input function, and this is the bias. This is a neuron. Please don't get it confused. So looking at this now. So let's say we have two network. We have two perceptrons. Let's say we have two perceptrons, and I told you they are linear. They are linear. We now decide to combine those two. We now decide to combine those two perceptrons together. So one is considering from this aspect, the other is considering from this aspect. Those are two perceptrons, and then they combine their results. So this is a, this is a layer. This is a layer. This is a layer, and this is another layer. and then you send this. So this was able to like divide the data. This is able to divide, and then when we combine it, we are able to like combine their results this way. So that is a basic example of neural network convolution. But when we now add, this is two layers, right? When we now add, we now do multiple layers like this. And let's say we are doing this. That means that they will learn a lot of things and probably overfit on your data set. This is why when you are doing a neural network, if you are using a deep neural network, that is why you also need a large data set, or else your model will overfit on the data. Is that clear? A large, if I build this, so this is the input layer. This is the first hidden layer, second hidden layer, third hidden layer, and this output. It is this output layer. That's where we put. So in this ones now, really we use really majorly in the intermediate in the hidden layers inside the network, and then I have this output layer. What kind of calculation form uh, considering what kind of acceleration function? Sorry, am I still on?
No, your line is breaking. It's like you asked a question. I didn't get that. I don't know if anybody got that.
I said we're considering this our output layer. What will be the activation function?
Considering these outputs now, we have, I mean, it's like more than one. So like we're looking at like softmax, right? Softmax.
Yes, we are looking at source matter.
Yeah, yeah.
Yes, that's what it is.
Thanks for that name,
So
cool.
because we
Actually,
are we have multiple oh, you got the answer from the link.
yeah. So I think, yeah. Like if it's like I just said the
No
softmax
problem.
is like combination of more than one sigmoid. So if you're trying to do multi-class softmax, yeah.
Exactly. I mentioned this. I mentioned this now. Or why you not hearing what I said? Probably because
Mm,
probably because my times or something. I literally mentioned this. Okay,
mm.
regardless. So when we are predicting more than one, when we are predicting more than two, we use a software. When we are predicting just two, which is binary, we use what? Sigmoid. So that is basically
Mm.
what we are actually that's basically what we are doing. So but in the hidden
So
layers now, we
mhm.
use random activation function. We use regular association formula. That is the most used within. There are different variations. There is the leaky relu. There's also tan H. That one is not like that was not like that one is not used much anymore. But most times we use relu and we use relu within, and then as the output we use either sigmoid or binary depending on what we are trying to classify.
Okay,
So
so
it's
so
as I said,
let me say something. Sorry for cutting you short. So now that relu now because what you just said, it makes so much sense with the code I see online every time. And code I see online, like they're regularly using relu as hidden and for inner layers. So is it because relu helps to? Is it because it helps with that? Going back to the first that definition of activation function, like is it because relu helps with understanding non-linear complex relationship, right? Is that why?
you know, it doesn't consider it. It's just like some zeros, anything below zero. And then when it just consider it if you want to let me well,
Um, Hello, can you hear me?
Yeah, I think the
I am
network.
back.
Okay, yeah, it's back.
Yeah.
Okay, so for my side, from my
I'm
understanding,
hearing
uh, people used to use Credit because it is very simple. Because anytime the coefficients are negative, it shrinks to zero. So it's mostly well known to be used when we are trying to do a classification with like not multi-classification, but binary classification. It's easy to, I mean, like to introduce linearity, non-linearity, and at the same time to shrink negative coefficient to zero.
Thanks so much, Aike. Thanks.
yeah. Thank you. So this is okay. See, this is it. As I was saying, thank you so much. Thanks. So once it is so it does like because it doesn't so as look I said the main advantage of using the real function value is that it does not activate all the neurons at the same time. So which is so means that the neurons will only be deactivated if the output of the linear transition is less than zero. Once it's less than zero, it doesn't consider it. So once it's above zero, it's smart system. So I think because it reduces the computation, in fact, it is computationally efficient when compared to sigma than time because those ones to consider everything. But this one makes helps also like sieve out the neuron that should be working at a particular time. So that's why it is majorly used. But depending on the task, so you can also there's also this flicky review that there's this really flicky review that does it like totally zero six, and there are some tasks that you prefer leaky review. There's also parameterized review. There are a lot of activation functions. Even right now, activation functions that are still being released, but they don't that are not as popular as these activation functions is. That's basically what Relu does. So that is why we use Relu. So within inside in the hidden layer we use Relu, and then at the end, so depending on our task, we can decide to use sigmoid or what sigmoid or what's the other one? Sigmoid or what? For multi-class, what do you use for multi-class?
Stochastic, what do you call it? Stochastic SDG, descent gradients. That's the one we use for
Softmax activation
multi-class.
Softmax.
activation function. We use softmax. But thanks
Yeah,
thanks so much
softmax.
for being interactive. Thank you. Uh, voice okay. So now I want to quickly explain this concept of with okay. One thing waste decay does is that okay. So remember what we're talking about regularization. When probably when you are training your model now, and your model to add too much importance to a particular ways the KFs to like penalize that. So that means that if you don't do that, it means your model is only learning from majorly from a particular feature. It is not learning as it should from the other features. So to ensure that your model is like learning from all the features, that is why we use waste statistics. So to penalize it if it's learning from if it is adding too much importance to a particular feature. So ensure that it is learning from all the features. So that is what waste decay does. Do we get that? Does that make sense? I know we already explained this before, but I
Yeah,
want to be
yeah,
sure.
yeah. That makes sense. So would that waste decay now? Is it going to be something like
Mm.
is it going to be L1 or like L2 regularization or something like that? Like because you
L2,
said
L2, it is
it,
L2 now.
it's L2. Okay, because it does not reduce them to zero. Okay. Okay.
No, it doesn't reduce it to zero. It doesn't take it to zero. It's only like penalizes it to reduce the importance it is giving them.
Okay.
So that the importance is like spread out across the features. That is what waste decay does. And so that's what it does. You can read more. You can read more. All this stuff. You can read more on it. And just
Sure.
this is just this is just, there's also
Yeah,
there's
okay.
also
Oh,
dropouts too.
exactly.
There's also dropouts. Look at this. This is what we call a deep neural network because it has like a number of like 18 layers, right? So what the dropout now does is that it's so that also just to ensure that the model is not like leaning towards so that it's not that only one probably in this layer now. So that it's not just only this particular perceptron is like is doing all the work. So to make sure that each of all these two also have a chance as training, they also do learning properly as they should. What dropouts means is that they add a percentage of skip in each layer. Okay, let's say if we do 10, I can say okay, let's say if I say that dropout is equal to 0, was 10%, right? So that means that of this one, each of these perceptron in this layer now has a 10% of being skipped during every forward pass. So like, does that make sense? This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So each of these nine neurons now has a 10% of being skipped. So I can say that okay, probably as right now I want to skip this one. So if and then right now I want to skip this one. So let's assume this in my while training my model now. Let's say all the importance, everything. It is this perception that is doing all the work. Hmm? If I now do a dropout and it is this particular neuron that has been doing the major work that was skipped, hmm, it will force all the other neurons, so force all of them to learn. So if everything is now converging on another neuron again, I can skip that one too. And say so I can skip that one too. And then all the other neurons will be forced to learn all the features that they need to, so that um the training is not like just focused on one neuron. Imagine when I have nine neurons in a particular layer, and probably just two or three. Let's even be generous. Let's say five or six are doing all the work, and there are three of them that are not even doing anything. So if they are not doing anything, but they are added to the computational um they are added to the computational thing of my model. So to make sure that they are not just actually doing it, that is what dropouts does. So that all of these so
Maya, the magnet one, the
no,
one
that's
there, right?
at least all of them are up. So if you say that this any of these
Huh?
at, so as some every I said that them each of them has a 10% of this script. So I will do so as all the layers. Do we get that? Does that make sense at all?
Yeah, yeah, yeah. It makes sense to prevent overfitting. Like it makes sense.
Exactly. Ever fitting and overfitting and the train is like distributed along the neurons. So overfitting. I guess this early stopping rates now. Um Early stopping rate does something. It helps to like so has everybody been able to draw to mark their to fill their attendance? Or you are able to fill the attendance form?
Yeah, me, I feel it. I think someone was saying that they couldn't open it, but I don't know if they reshared it again.
Yeah, that's why. Can someone just reshare it, please? Okay,
Okay,
so early okay.
right.
This early stopping rates. Now I want to let me see if I can.
Okay,
I want to show one example of something I did recently. Okay. Um, okay. Let's see if this. Let me see if I, let's see if this comes up. So early stopping rates, what it does is that before a model starts to overfit, it stops it. Hmm? Okay. This I was training one particular large language. So look at so this is the training loss. This is the evaluation loss. Can you see this?
Yes, we can see it.
Can you all see this?
Yes.
So this is the okay. This is the evaluation loss, and this is the train loss. You see that it's so I reduced up to a point. So what early stopping race does is that it's happening for it right after a number of steps or a number of epochs, and there's no significant change in the evaluation loss. Hmm? So it stops it. I use an early stopping. So early stopping patient, I use during this trade, I use an early stopping patients of 10. So after like 10 points of evaluation. So I was evaluating it at every 100 steps. So after 10 steps of evaluation and there was no significant change in the evaluation loss, it ends the training. So once it ends it will avoid it like so it will avoid the even though it will avoid the model from it will stop the model from overfitting. Because the thing is the training loss can still like keep reducing. But once the evaluation loss is not reducing, and training loss come down, this is a very this that's not very at some point if it is not stopped, it will now like keep moving up. So that is what early stopping rates. That's what it does. So we get that.
Yeah, yeah, I feel that. Yeah.
Sorry again. So let me round it. So then we talked about back propagation and so I think that's just so yeah, data augmentation. I talked about this data augmentation, like zooming in picture, setting the pictures at different angles to to increase your data size and so back propag so this is what's back propagation what's back propagation. So when you do it, so this is what backpropagation does. It helps us to spread the error. It helps us to spread the error to each of the weights and this one. So based on this, the data calculating the use it of this data calculating the weights. After calculating the loss, then now it's back propagation to that. So this is basically putting it all together. For propagation that loss function measures the error. Back propagation computes the gradient risk weight, gradient descent of this the weight is gradient gradient. So evolutional that was good. This is the right picture.
So,
I won't, I
honestly,
will just, you can go
okay.
and check the, sorry?
Like I wanted to say something, but because of the time is going, I also wanted to say that from the back propagation, right? Because actually in his statements in the slides and in the video, he was like, now it's time for I can't remember. The slides are not open, but he was like, okay, when he moved to the back propagation slide, he was like, okay, now like you know what the perception is, you can now begin to actually train the neural network. So and I also did some research on that. Like I followed up, and it seems like propagation itself is like the training of the model. Like that's when it actually learns. So I'm just asking, and just wanted to get your own like opinion on that. Like, would you say that that is true? That propagation is when the model is actually like being trained or learning. Actually, yeah.
Because
Please,
that is when the weights are being updated.
yes, I would say that, can I talk?
Yeah, sure. I mean, we're all
Yeah,
here.
It is,
okay, thank you. I would say that backpropagation is when we are
let
trying
me say
to,
something.
huh?
Okay, I was talking.
Backpropagation is, from my understanding, backpropagation is when we are trying to correct our
Proceed,
error
proceed.
such that the predicted value is the same as the output that we desire. So when we are updating, the weight is kind of like we are trying to correct this error by doing it like we are using backpropagation, but we are doing it in the we are starting from the output to go to the input layer.
Yeah. That is true. So the thing is, back propagation is so that's this when you after you calculate, so this is it. Forward propagation now. You run a prediction. So and you get prediction based on like depending on the weight your model has assigned to each features, right? So first, front. Okay, okay. What are you seeing now? What are you seeing? I see my collab.
Yeah, yeah, I can see your collab notebook.
Okay, okay. So let me come back here. Prediction, you compute the prediction. Normal. That's step one. Compute prediction based on the I said based on the feature, based on the importance, which is weight that the model has initialized for each of those features. Okay, so you run the fraud prediction, which is the prediction. Hmm? So after running the prediction, hmm, the second step is that you now calculate the loss. The loss is now like the difference, the error between the prediction and the and the and the what's it called? The error and the prediction and the error. Exactly. So that is loss function. So back propagation now, this is where this is where we now like calculate, like, okay, we now calculate the gradient with respect to, we're talking about loss, we're talking about gradients. We're talking about the gradients. I don't know if you remember. We're talking about the gradients. So we compute the gradients with respect to the weight. So when we so that is so that's the compute, that is when the model learns. So gradient does not help us to update it and update the weight. So it does that. Okay, this is the new weight, and I'm taking this particular steps. I think I'm taking this particular new number of steps, which is the learning rate towards what's it called? Towards the new prediction. Let me come here now. First of all, you do a forward pass. Then to calculate, okay, after you get the output, remember you have the after you get your prediction, remember you have the true prediction. So ah, you now calculate the loss function. Yeah. Abi.
Yeah.
So back is that now do chain rule. Okay, let me do a bit of mathematics. So back from this output here to the in. Do you get?
Yeah.
So yes, of this one with respect to this, of this one with respect to this, of this one with respect to this, and of this one with respect to this. It is mathematical, but I don't want to like go. I don't want to go too deep. So after calculating the gradients, what did I call is the next thing? You now do not the gradient. After you compute the gradient, so you now using the learning rate. So after so you now so if this is if the way is here before, so you now change the way to this point now. And after that, we'll now do another forward propagation again. There is it. So after that, now come back again. So and this cycle keeps until they are able to get until our model gets to until the loss is something very low. Do we get that? Does that make any sense?
Yeah. So
So I won't
yeah. So
be
from that image,
concluding.
okay, I was going to say that, so from that image now, that means, yeah, I was going to say that from that image now that you showed us, right? The activation function was like the the activation function was like softmax, right? So that means that for every epoch, that's when it goes forward and backward, there will be gradient descents for all the losses that it computes.
I'm hearing you. Zoom I need to. This is my. I think this is my hearing.
Hello, hello.
Yeah. I can hear you now.
Yeah, I
Hello.
was saying that. I was saying that in this situation,
Hello.
and yeah, I the network the network is bad. Damn.
I hear you. I'm hearing you now.
Okay, you can hear me now. Yeah, I
I
was
can
saying.
hear you.
Yeah, I was saying
Yes.
that the every time that's for like an epoch is when it goes forward and then comes backward. That's one epoch. That's one forward propagation and one backward propagation. So like so every time it does that, right, there will be gradient descent computed for each loss every time.
Yes. Yes. every time,
Okay. Okay, that's what
every time. So it goes forward. Once it runs the prediction, then it runs the it runs the back propagation gradient descent and do you get?
yes, I follow best. Yes.
Do
Yes.
you get? Sorry, I don't know. Am I still audible? Okay.
Yes,
So and then
yes.
it run a full so emphasis on the output, house prediction, get the results. You see how far the result is from the original, which is from the origin from our ground truth, which is the original prediction. They're using that information that you now like compute the loss and then sorry, I've seen enough of this culture by it. I don't know what to do. So, so, so how you go I said am I audible?
Yes, yeah.
Hello, am I audible?
Yes, you're audible.
Hello. Okay. So I guess that is that for trying to talk it. This my network has frustrated me now. I am stressed. They won't spend much more than expected. So please, with this theory that we have done, go through the lab. I sent the link to the lab last night. I sent it to the unedited one. I sent it to the Discord channel. So you can go through it, and if there's any question you have, please let me know. I won't be able to go through. If you don't understand the theory, there's no way we'll understand it. And if you don't drop your questions on the channel, let's meet by next week Saturday. Okay?
Yes,
Hello, am
boss.
I audible?
Yes, boss. Yes.
Okay.
Yes.
All right. All right. Let's call it a. Okay. Proceed, Israel.
Yeah. So I was away for a while. For a while, I think about 2 or 3 classes like that. So I'm already
Okay.
picking up everything. Of course, everything is on the YouTube channel now. So I'm already going through
Mhm.
everything. Although my project, I've not submitted what's it called? Is it proposal or what was the name? I've not submitted it. I want to do. Can I see submit that today?
Are you in a team? Do you have a team or just you?
Um, I should be able to. There's someone I know also, which is not also here. I'll try reaching him. But if I'm unable to get a team today, I should let you know. But if it's only me also, I'll also let you know. But of course, I don't want to give up.
Thank was earlier. I think was it Arike that was asking about joining the team as well. Is it Arike? Oh, I'm not sure if it was Arike. So she was what Teju said earlier was that probably you should like simplify on the channel if there's anyone that's still like interested in like, there's not an opening in their group that can take you. Feel like time has come something to do. But I think that was because it was only Arike. But I think it was Arike. I'm not sure if she's doing. So, but probably if you and the person that spoke earlier and that your other person, if probably if you guys are able to like you know come together as a team, probably, and then you tag Tejo on the group and talk and tell her about it. So if you guys are able to form a team successfully, then that's what probably to look into. Else, you can just like notify on the group that you need a team. So if there's anyone that's available to accept you, do you get?
Yeah, I got that. Got that. I'll do
If there's
that.
anything that doesn't, but you can. All right. Any other question before we leave? Thanks. So this is the end of week 10. This is the end of lectures in machine learning, the fluid ML course from AI accessibility. We should still come around by next week just for that. Let's say 200. Well, if you still have questions regarding this topic, I know I know this is a new, they say that we are diving into new water. So if you still have questions, please reach out. Let us know. Let me know. You can DM me, you can ask on the group chat. If it is question of this topic, you can definitely ask on the group chat. It can benefit somebody. And if there are much if there are more if there are aspects that you feel like are very conflicting, you can bring your questions, or if there are more, you can bring your questions in the group. I mean on the call next week. It's not present. Is that fair enough?
Yes. Yes.
Okay, thanks so much for your patience. Thanks so much for everything. Thank you. We really love and appreciate you. Thanks for sticking with us for this 10 week journey. If you have pending assessments, please submit them. If you have pending assessments for the week, please complete it as soon as possible. We will close all assessments. We'll close everything soon. The ones that we not close, we'll close everything. So if you still need to go and check it, please do that. Thanks so much. It's been nice knowing everybody. It's nice seeing everybody. Yeah. Sorry we spent a bit more time today. I know so I don't know what happened. Yeah. So yeah, have a nice enjoy the rest of your weekend.
Yeah, and you too. Enjoy the rest of your weekend.
Thank you, my friend.
Oh, Elijah, I've not heard from you since morning. Where were you?
I'm fine. I've been silent today, but it's okay. I'm fine.
What happened?
Not really. Just have
I didn't
some
even see I didn't see your
urgent
text.
tasks from.
I didn't see your text. Sorry.
It's okay. I'm fine. Thank you. I'll reach out on Discord.
Okay.